Okay, grade 8. This is your last for preparation prior to your actual final exam on graphing linear relations. So here we have 4 questions, all 4 of which are good examples of things you should be able to do by the end of the unit. The first 3 questions are the tools to be able to do the 4th question. If you can do that 4th question without looking at 1, 2, and 3, if you can do question 4, I know you know what you're doing because that is what we're working towards. This is the end goal of all of the work we put in the first 3 questions. So, here we go. Question number 1. I've given you a graph with 3 points. The 3 points are written in red. And the question says, if I give you a graph with 3 points, can you give me a TOV, which represents table of values, an equation, and these 2 points, 100 comma y, the ordered pair. Can you tell me what the y value if x is 100? And in the second ordered pair, can you tell me the x value if the y value is 515? And we'll get to those 2 points in a second. But the first thing you want to do is you want to make a table of values. And I'm going to do it over here. And we all know that the horizontal axis is your x, and the vertical axis is your y. So I'm going to press or write x and y right up there. And I'm going to look for ordered pairs to put into those positions. Now the first x is 1, and its corresponding y value, this point here, is x1, y 110. And you learned that last year in grade 7, back in September when you did Cartesian planes. So that ordered pair has an x value of 1 and a corresponding y value of 110. Then if I look at the next one, x is 2, y is 125. That ordered pair would be 2 on the x and 125 on the y. And finally, the next one, 3 and 140. And the important part to see is when I take those 3 points and plot them on this graph, an interesting thing happens. The 3 points, when connected, when the dots are connected, form a straight line. And what this means and why we're doing this is it means the relationship between the ordered pairs is linear. And when I say that, that means that there is an equation, an algebraic equation, that can be used to express all points on that line. Okay? And our job is to be able to find out what that equation is so that if I wanted to find a different point, like we have in these 2 questions here, because I have the equation that is defining the line, I can then find any value as long as I give you one of the pairs. You should be able to therefore tell me the other value. So, with that in mind, this first one says, what is the equation? And the equation we have learned to do is we said, well, if you wanted to find the equation that shows the relationship between x and y, typically there will be a coefficient to that equation, and there will be a constant. In grade 10, you will learn that these 2 things have to do with the slope of the line meaning the steepness of the line, and you will also learn that the other value has to do with the what we call the y-intercept. But for purposes of grade 7, 8, and 9 math, we don't care. The y-intercept means your constant of your equation will be telling you where that crosses the y-axis, and the coefficient will tell you the steepness of the line. But again, like I just said to you, we don't care about it in grade 7, 8, and 9. That's something reserved for grade 10. Just be aware that you will eventually learn these 2 things, but for the time being, you don't have to worry about it. So, the first thing we need to find is this one here, this coefficient, or as you would learn later, the slope of the line. And we get that by finding the rule for the coefficient. The coefficient is the difference in the y column divided by the difference in the x column. And when I find those 2 differences, that will tell me my coefficient. So I'm going to go down here and say, well, what is the difference in the y column? It's adding 15 each time. And the difference in the x column is adding 1 each time. So if I take the difference in the y, which is positive 15 or adding 15, divided by the difference in the x column, which is adding 1, 15 divided by 1 is 15. And that 15 is the coefficient in the equation that shows the relationship between all the points. So I know my coefficient. So step 2 is, is there a constant? Is there a constant that balances the 2 sides? So I'm going to write my partial equation of 15 times the x value equals the y. And in order to find out if there is a constant necessary, you can take any of these ordered pairs. You can take this one, you can take this one, you can take this one. And generally speaking, we always like to use the first one because it's the smallest of all the numbers we have. And I'm going to take this x value of 1 and substitute it into the equation. And I'm going to take the y value of 110 and substitute it in there. And I'm going to ask myself the question, is 15 equal to 110? And of course the answer is no, which means we need a constant. We need one. We need a constant to balance the two sides. And that is a simple way of saying, well, 15, which is plus what, is 110? And the answer to that is 95. So all along here, the constant necessary to balance the two sides is plus 95. And therefore, I now have the equation that expresses the relationship between the x values and y values in that entire line. And as Ben did, oh, that's not what I want to do. Let's erase that. Let's erase that again. Then you could take your marker and write 15 times the x value plus 95 will equal the y value, and every point on that line will fit into that. So, back to this. This point here said the x value in our ordered pair, because remember, ordered pairs have two values, an x value and a y value. X is always the first one. X is 100, and then what is the y value? We don't know it. So then what you do is you say, well, I know the x value, so in my equation I will substitute it, and I will simplify it, and I will determine that if x is 100, then the corresponding y value will be 1,595, and that would be an ordered pair. So again, if I was to extend this line way out to 100, and I was to extend this line all the way up, and I was to extend this line all the way around, whenever I got to x equals 100 and went up from there, the corresponding y value where it met that sloping line would be at 1,595. The second ordered pair here, this time I don't know my x, but I know that my y value is 515. So again, I take my equation, and this time I'm going to substitute the y value that I know into the equation. I'm going to put 515 here. And when I examine the equation I have now, I really have a grade 7 two-step algebraic equation in which I can subtract 95 from both sides to get 15x equals 420, 420? Sorry, 420, not 520. 420. Divide both sides by 15, and 420 divided by 15 is 28. So therefore, x will equal 28. When y is 515, the corresponding x value will be 28. Okay, that's a lot of writing on that board, a lot of red, a lot of black, but if you go back and listen to it again, you probably will understand a little bit better if you were a little confused in that first time. The second question, we're given an equation and we're not giving anything else. So what we have to do here is the first thing we're going to make is a table of values. Okay, now I told students in the last class, you have to randomly choose values for x. Now I would choose 2, 4, and 6, but generally you can choose whatever you want. The normal person is going to go 1, 2, 3. And once you have those values in, take your equation and substitute the x values you gave into it each time to get your corresponding y value. So when x is 1, 1 divided by 2 is 0.5. And 0.5 plus 3 is 3.5. So the y value when x is 1 will be 3.5. When x is 2, substitute it where the x was. 2 divided by 2 is 1, and 1 plus 3 is 4. So the corresponding y value is 4. And finally, in my other one, when x is 3, 1.5, which is 3 divided by 2 plus 3, equals 4.5. So now I've created my table of values, and I'm ready to go. So now I have my equation, I have my table of values, and now I have to graph it. So I'm going to put it here. The range of values of my x are 1, 2, and 3, so I can fit that nice and neat down here on my x value. Here I have 3.54 and 4.5. I could probably put them all in, so 0.51, 1.52, 2.53, 3.54, 4.5, that's as far as I need to go. 1 and 3.5, so that's 1, 2, 3.5 is there. 2 and 4, 3 and 4.5. I know these aren't exact, but you can see from that that they do fit. And the equation for this is this particular equation. And now I have my graph, I have my table of values, and the only other thing I need to do is say when x is 100 and when y is 19. So again, just substitute that 100 up here in your x. 100 divided by 2 is 50, and 50 plus 3 is 53. So when x is 100, the y value will be 53. And finally, in the last question for this particular part, I'll put my x back up here. When y is 19, what is the corresponding x value? Again, we just have a two-step algebraic equation. I'm going to subtract 3 from both sides like I would in algebra. Half of a number equals 16. Multiply it both sides by 2, and x will equal 32. Okay? So there we have the solution to the second question. How much time do we got left? 3 minutes. Let's see if we can do this. In the third question, you're given a table of values only, and you're asked to give me the equation, the graph, and the missing values. So just like before, we're going to put our x equals y. Find the difference here and the difference here. It's going to be 4, positive 4 divided by a positive 1, which means the coefficient is a 4. Substitute your first ordered pairs, so the x and the y. In here, we have a 1 and a negative 4. 4 does not equal negative 4, but 4 take away 8 does. So therefore, your equation that matches the table that was given is 4x minus 8 equals y. Okay, now once you're given that, well, actually you don't even need it, but you can graph it. Your x values have 1, 2, and 3. Your y values go negative 4. Oh, look at this. I forgot about this. They go negative 4 to positive 4. So the first one is 1, negative 4, which is here. Your second value is 2 and 0, which is right there. And your third value is up here. When I connect the dots, it's reasonably linear, and that is the graph, the name of which is this. And finally, the missing values, when x is 100, substitute it into your equation, simplify it, and find out that y will equal 392 when x is 100. And again, in that same equation, this time I know my y value. The y value is 256, so I'm going to substitute it right there. Instead of y, put 256 to find out what the corresponding equivalent x value is. Add 8 to both sides. 4x will equal 264. Divide both sides by 4, and you get x equals, I'm not sure, 264 divided by 4 equals 66. So x will equal 66. Any questions so far? All right, and your last question, this is where it all kind of the rubber hits the road. This is what it's all about here. If I give you a pattern, and this pattern starts with $1.10, $1.85, and then 260, and then it says, what's the next number? And then dot, dot, dot. What would the 100th value in this sequence be? And in order for you to understand this, or in order for you to be able to calculate that 100th number, you kind of have to understand everything we've done in the previous questions. So the first thing says, make a table of values. Now the tricky part to this is that your table of values usually has an x and y. But for this particular question, we're not going to use x, and we're not going to use y, and we're going to think about this a little bit, and we're going to redefine them according to whatever the information given is. And in this case, we have a sequence. So the first one we're going to use n, and that represents the number in the sequence. So n stands for number in the sequence. Okay, so we have our first number, our second number, and our third number, our fourth number, and our 100th number in the sequence. The next one we're going to call is the v, and you can call it whatever you want. I'm just using n and v because to me it makes sense. You could call it, I don't know, S for sequence number, and you could call it D for dollar amount, right? It doesn't matter what you choose. I'm using n and v because to me, these make sense how I'm defining it, the value. And the value of the first one is $1.10. The value of the second one is $1.85, and the value of the third one is $2.60. Now that I have my table of values, I want to see if there is indeed a pattern, if it is indeed what we call linear. And in order to be linear, if it is linear, then there's going to be an equation. So if the difference in these columns and the difference in these columns for the 3 points that I have, if it's consistent, if it goes up or down consistently in both columns by the same amount, then when I graph them, what will happen is there'll be a line, and that line will then be able to be an equation drawn up for them so that all points on that line, as it extends to infinity in both directions, will be able to be determined using algebra. So if I look here, it's going up by 75 cents. And here, it's also going up 75 cents, which is a good thing, because here it's going up by 1, and here it goes up by 1. So that means in the equation that shows the relationship between the number in the sequence and its value, the coefficient will be the difference in, this time, the V column, which is 75 cents, divided by the difference in the Y or the X column, which in this case is N. And that is going to give me a coefficient of 0.75 cents multiplied by the number. Plus or minus something will give you its value. So is there a constant? Well, let's take a look at this first ordered pair, 1 and 1/10. So 0.75 multiplied by 1 is going to equal the value of $1.10. Now, since we know 75 cents does not equal $1.10, there has to be a constant. And in this case, that constant is going to be adding 0.35 plus 0.35. And now what we have is we have determined what the equation is that shows the relationship in this pattern. And because there is an equation, I can find any number of points anywhere between those. So I'm going to graph this first to show you what it looks like. So here is my graph. First number, second number, third number. So I'm going to have 1, 2, 3. I'm going to call this the N axis. And then I'm going to go $1.10, $1.85, at $2.60. It's going up by 75 cents each time, and it's going to make it really difficult to graph. So what I'm going to do is I'm going to squish this line down, and I'm going to omit everything from $0 all the way up to my first number, which is $1.10. And then what I'm going to do is I'm going to cheat a little bit, and every one of these numbers is going to go up the predetermined dollar or 75 cents that I need it to. So the first number is $1.10, the second number is $1.85, and the third number is $2.60. Connect the dots, and if I go to infinity on this line, that line can go forever. So 4, if I was to what's called extrapolate the data, and I was to extend this line a little bit further, the fourth number would be this point right here. So the fourth number in the sequence, I don't really know what that is. I can assume it's going to be 75 cents more because it goes up by 75 cents. So it's going to be $3 and 40, 20, 35 cents, 3.35. So the fourth number in the sequence, according to this line, if I extrapolate that point right there on the line that I didn't have, but if I extend that line forever, it should be 3.35. And that makes sense because adding 75 cents, just like we said, should give that. But if I take my equation and I substitute that n, instead of being n, I'm going to make it the fourth number in the sequence. So I'm going to substitute it for 4. And I simplify it. Well, 75 cents times 4. Well, 75 cents times 2 is $1.50. Times 4 would be $3. Plus 35 would be 3.35 equals the value, which is what we already ascertained by just adding 75 cents to the number. So the fourth number in the sequence, when I plug it into my equation, becomes 3.35. And again, if I take that equation and erase the 4 this time, because it really asks for what is the 100th number in the sequence, then 0.75 times 100, well, when I multiply by 100 and move my decimal 2 places, is 75. Plus 0.35 would be 75.35 equals the value. So therefore, the 100th number in the sequence will be $75.35. So if I extended this pattern and wrote out all the first 100 numbers, I would get this number here as my 100th number in the pattern. And by doing it with algebra, we can obviously see that it's a lot easier for us to figure out what the 100th number is if I create an equation than it would be if I extended it. Because then, if I asked you what the 1,000th number is, you couldn't possibly extend that 1,000 numbers. But I would know, since 1,000 times 75 is 750. The 1,000th number in the sequence would be $750.35, right? And I did that just because I knew my equation.